Hello, welcome to this MATLAB video tutorial. Today we will learn conditional statements and loops. Also, we will see how to use the MATLAB debugger, which is a very useful tool to find bugs, errors in a code. So let's start. First, we will define our working directory. That's very important. So today I will work in my desktop, MATLAB introduction, and I will define a new folder. Here I will call it session C3. So I will define as my working directory today this path, okay? Session 3. Remember that in path names it's very important for MATLAB that you cannot use spaces, accents, strange characters. If you need a space, you can use the underbar, that's allowed. Okay, now to start, let's explain who are logical variables and who are relational operators. So let me show you here. Relational operators are this type of operators. For example, if I write in MATLAB two equal signs, this means I want to compare. Let's say, is 1 equal to 2? You see, I'm writing two equal signs. So what I'm asking MATLAB is, can you tell me if 1 is equal or not to 2? And in this case, the MATLAB answer is going to be no. So this result is a logical variable, and the way MATLAB says no is a 0 value. Now I can ask, for example, if 1 is smaller than 2, then the answer is going to be yes. Again, this is a logical variable. The way MATLAB tells us it's yes is a 1. Logical variables always have value 0 for meaning no, and 1 that means yes. Okay, so we can use these relational operators: equals, minor, greater than, minor or equal than, greater or equal than, and this one that means different. So if, for example, is 1 different to 2? Yes, the result is yes. Now, then we have logical operators, which are and, not, and or. Okay, so for example, I can define A equals 1, B equals 2. Now we will see in the workspace these variables appeared here with value 1, value 2. Now I can ask, is A greater than 2 or it's B smaller than 3? Now let's think about this. A equals 1, so 1 is not greater than 2. But this is an OR statement, so I will check second condition. It's B, which is equal to 2, smaller than 3? Yes. So in this case, this statement is not true, but this second statement is true. So the result of this OR condition is this or this one true is going to be yes. So I get a 1. Okay? So these relational operators are very, very useful to define conditional statements. Sometimes when we program, we want some statements to be run just if some condition is satisfied. So to do that, what we need is the if sentence, the if command. If we write help if, we will see here that the if command allows us to conditionally execute some statements. And the general form of the statement is this one. If some logical operation is satisfied, then these statements are executed, and then automatically we go to the end of the if condition. However, if this expression is not true, then I will check next condition. Else, if this expression is true, if that happens, then it will run these statements, and then go out from the conditional statement. Finally, if this expression is not true, this expression is not true, then the else last condition will be executed. It's very important that the else if and the else part of this statement are optional. You can just use an if, an expression, and an and. And it's very, very important that when the expression is true, it executes the corresponding statement and exits the conditional. So it does not check the other expressions. Let's do a main program as an example. So I will new script. Let's write down here a program that will use an if statement. Let's say that this program inputs from keyboard the value of variable x, and then checks if it is a valid value in between some range. Okay, so first let's input from the keyboard some value. So we will write x equals, and then input, and then we will ask for some value. We will say, for example, give a value. After that, we will check if this value is in between some range. Let's say we want this value to be between a minimum value of 0 and a maximum value of 100. Okay? So the conditional will look like this. We will write if x is greater than or equal the mean value, and at the same time x is smaller or equal than the maximum value, then I will display on the screen perfect. This is a perfect value is within the specified range, for example. Okay? Else, if the value is, let's say, greater than the maximum value, maybe I will display something like, sorry, value exceeds maximum value. Sorry, value exceeds maximum range or value. And finally, in any other case, else, in any other case, if this is not the case, that means that x must be smaller than the minimum value. So the else condition can be a display of, sorry, value is below minimum value. And end. You see, it's very important that you end the if statement. You can see that the MATLAB editor has colors detection. It tells you which are commands, MATLAB commands, what is text. He identifies that this part is text that will be displayed. Okay, so this is the main code. It's a very simple program. Let's check if it works. Okay, so let's save it. We will call it main if, because we are doing this program just to work a little bit with the if statements. Okay, save. Now let's run it. Now in the command window it says give a value. So I know I will give -1. Then it says sorry, value is below minimum value. So I can run again with the up arrow, I run again main if program, and give a value. Okay, I will say 101. And it says, sorry, value exceeds the maximum value. So now I can try again, main if, give a value, maybe I can try with 45, yeah? And it will say, great, perfect, values within the specified range. So this is just an example of how you can code an if statement. Here we used the else if and the else options, but you could just use a very simple if with one condition, statements, and the end. Okay? Let's do another example. Let's do a function. Okay, let's do a function that computes the minimum between two values. So let's do a new function. When we do a function, we need to specify who are the output variables. We will have one output variable, m, that will be the minimum between two values. So the name of the function will be minimum. And the input variables are going to be, I will call them A and B. And let's explain here who is this function and what it does. I will start explaining how I call this function. We always call a function the same way we define it. So the call to the function will be always like this. Now let's specify what this function does. Let's explain. So this function computes the minimum value between A and B. Okay. Now let's write down very clear who are the input variables, in this case A and B, and who are the output variables. In this case, the output variable is called M, and it contains the minimum value between A and B. Okay, how will we code this function? Okay, this is a very simple if conditional. We will write if A is smaller or maybe equal to B, then the minimum is A. Yeah, so the output variable M should take the same value as A, which is the minimum. Else, in any other case, means that B is greater than A. Sorry, that B is smaller than A. So in that case, the minimum is B. So the output variable M must take the same value as B. And yeah, that's it. This is a very simple function. Let's save it. Remember that we must save functions with the same name. The name of the file must be the same as the name of the function. So I will call it minimum. You will see here the function appears in my current folder. And now I will run this function. Remember, the only way to run a function is to call it in this way, either from the command window, either from a main file. So for example, I could just come here, copy this, go to the command window and write something like this. But then I need A and B to have specified values. In this case, if I look to the workspace, I see A's value is 1, B's value is 2. So in this case, the minimum between A and B should be 1. Yeah? I could also introduce here by hand different values, 2 and 6, for example. Of course, the minimum is 2. Another way is to write a main script where I can call the minimum function for different values. For example, I will compute the minimum between 1 and 3, and I will store the output in a variable called A. Note, I can call this variable whatever I want. I call it here A. I don't care if here is called M. This is the output variable, so when I call it from the main file, I can call the output variable as I want, okay? So maybe I call again this function and I compute the minimum between -1 and 5, and maybe I call again this function and I compute the minimum between 30 and 20, for example, okay? So if I run this file, first I will save this. Let's call this main minimum, because it's a main script that tests this function. And then I will run it. And what I get in the command window is that I get the value of A, the minimum between 1 and 3, which is 1. B is the minimum between -1 and 5, of course, -1. And in the case of C, the minimum here is 20, so that's what I get. Yeah? So this is a very simple example where we use the if conditional in a function, then we call it from a main script. So that's everything I wanted to explain about the if statement. Now, another useful command is the for command. Sometimes within a script or a function, we want to loop over a section of code. And the way to do that is using a for statement like this. We will write for a variable that normally is called the counter, because it will count how many times we loop over these statements, and a start value for this counter variable, an end value, and maybe a step. If you want that step to be 1, then you don't need to specify it. By default, is 1. Okay? So we can write an example using this for statement. Let's write down a main program that computes the summatorial of, let's say, the first n natural numbers. So let's do script, and let's say we want to do a program that computes the summatorial of the first n natural numbers, where n maybe is an input from the keyboard, okay? So I will start clearing all my variables, clearing the command window, and then I will ask, using this input command, that somebody enters using the keyboard a natural number. So give a natural number. And then I want to make a sum, yeah? So I will call summatorial to the variable that will, at the end, have the final value after summing up all these natural numbers. But I will initialize this variable to 0. Now what I want is to do a for loop for, now I need the variable, a counter. I will call it I. From I equals 1 up to n, and I want the step to be 1, so I don't need to define it, because by default it's going to be 1. I want to add to my variable summatorial its previous value plus the new value I want to add. In this way, when I enter here in the for loop, I will be equal to 1, summatorial will be equal to 0, and 0 plus 1 would be 1. Then I will go again back here, then I will be equal to, so I will have 1 plus 2, which is 3. Then I will go back here, and I will be equal to 3, and I will add 3 plus previous value, which was 3, which is going to be 6, and so on. I will not write this semicolon here, so we will see what it does at each step of the for loop, okay? So let's run this main file. I will call it main summatorial, for example. And let's run it. Give a natural number. I will give a small one just to see what it does. Yeah? 3. And then we see the value I give is 3, and then it will start the summatorial. Initial value 0 is not prompted out here because there is a semicolon. But the first time it goes in the for loop, 0 plus 1 is 1. Yeah? Then second time we are in this for loop, 1 plus I equals 2 is 3. Yeah? So the summatorial variable now, its value is 3. And then I go back here and I equals 3, which is the value of n. So that's the last iteration. And summatorial was 3 plus I equals 3, that's 6. So that's the final value. And then it ends. So this is a very simple example of a for loop. For loops are always used when you know exactly how many times you want the code to be executed over a given section. Okay? We can do a second example. For example, we will sum all the components of a vector. Let's do a new script. And let's say we want to do a program that sums all the components of a vector. Okay? So for example, we will clear all the workspace, clear the common window. Then I will define a vector. 3, 4, 5, 6, 7, 8, 9, 10. Okay, so this is a vector. It has 15 components. And what I want to do is I want to sum up all the components of this vector. So the way to do that is using a for loop. What I can do is for I equals 1 up to the length of this vector, because I want to add all its components. So here I will write the length of vector v. This command is going to tell me the size of this vector, how many components has the vector. In this case, 15. Yeah? So for I equals 1 up to the length of v, I want to add the new component. So what I need is to initialize a variable s. I will call s equals 0. Okay? And here s will be updated with its previous value plus the new value I want to add given by component I in vector v. Yeah? At the end, I will show the value of s. So what I'm doing here is at each for loop, I add to the variable s the next component of vector v. Yeah? So we can take out this semicolon, so we will see all the steps of the for loop. Let's save it. I will call this main vector. And let's run it. So here we see it was quite long vector, so we will see that the first time we enter in the for loop, s equals 0, and the I equals 1, so the first component in the v vector is 1, so that's why the first value here, s equals 0 plus 1, 1. We'll go back here, now I equals 2. So now s is going to be the previous value, which was 1, plus the second component of the vector, which is 3. Yeah, the value stored in the second component is 3. So 3 plus 1 is 4. Then we go back here and I equals 3. 3 is still smaller than the length of v. Yeah? So we keep on. As I equals 3, I will update s with its previous value, which was 4, plus the value stored in the third component, which is 5. 5 plus 4 is 9. Yeah? And in this way we proceed until we add the 15 components of this vector. So this is how a for loop works. That's what I wanted to explain about the for loop. And the last statement I want to explain is the while statement. A while statement is used when you want to loop over a section of commands, but you really don't know how many times you want to loop. Yeah? In a for loop, you know exactly how many times you want to loop over that statement, but in a while, you can introduce a condition, and when that condition is satisfied, then you stop looping over those statements. So the way you write down a while loop is this one. While some expression is true, these statements are executed. We go back here, we check again. If the expression is still true, we run again these statements, and so on, until this expression is false, and then we exit this while. Okay? So let's do an example. Let's write down script where we will approximately compute the root of a function. So let's start clearing the workspace and the common window, and let's define a function, a mathematical function. Let's say this is the exponential of x plus the sinus function. And what I want to do is to approximately compute where this function cuts the x-axis. So I want to compute a zero of this function, a root of this function. I'm going to use a method which is called Newton's method. But that's not important here. The important stuff here is that I want to keep on with this method until a condition is satisfied. And the condition is that I want f of x to be smaller than some value, because I want f of x to be almost 0. Yeah? So I will start with x equals 0, and I will use a while loop. And I will say, while the absolute value of f of x is greater than, I don't know, maybe 0.0001, okay? Quite a small value. It could be even smaller. This is just a test. When I evaluate the function f at point x and in absolute value is smaller than this, I want to exit the while loop. So while this is bigger than this value, I want to loop over the next statement, which is just a method that is called Newton's method. This is not important. This is one step of Newton's method. Okay? So the point here is that we will loop, we will iterate with this method while this is greater than this value. When we find that this is smaller, then we will exit and we will assume that the value of x is good enough for us, is inside this tolerance. Yeah? So maybe we will show the value of x. Okay? Note here that for this method, I need the derivative of f. So I will write it here, which is the value of the derivative of this function. I will just compute it here by hand. The derivative of the exponential is itself. The derivative of the sinus is the cosinus. Okay. So this is a very simple script. I define a function and its derivative. I give like an initial value, x equals 0, and I will loop using this method until the value of x is such that when evaluating the function at this point, the value is quite small. So I assume that this is very, very close to the 0 of the function. Okay? So let's save this. We will call this main while, because it's just an example of how to use this while statement. And let's run it. And then we will see that the final result is minus 0.5885. We could use format long in order to see more decimals. Let's run it again. Okay, so this is an approximation of the root of this function. Yeah. So for example, if I could plot this function, yeah, I could say x equals values between -1. I will plot quite a lot of points. So in a step of 0.01 between 1. Okay, I define these points between -1 and 1. This is just for plotting purposes. And then I will plot x, f of x. What I'm doing here is giving the values in the x-axis are these values. And then MATLAB is going to plot in the y-axis the value of the function f at that point. Remember here f is defined. Yeah? So when I do this, I can approximately see where is this function crossing the x-axis, which will be at 0. So it's closer to 0.6 visually. Yeah. So it makes sense that the approximated value is minus 0.58. Yeah. Okay, so that's about the while statement. And finally, I want just to show you how the MATLAB debugger works. The MATLAB debugger offers the possibility to run a program step by step. So you can check the variable values. You can check whether the program is doing what you expect it to do, or maybe if it's doing something different. Yeah, maybe you have some bugs, some errors in your code. So I don't know, let's run this program, okay, which is a very simple one. Let's run this program using the MATLAB debugger. The way to use the MATLAB debugger is to place in one of these small arrows a breakpoint. This red dot is telling us we have a breakpoint here. So when I run the code, it will stop here. And it will wait for you to do what you want, to check values of variables, to check counters. Here you will see in the command window that this K letter appears. This is to remind you that you are in debugging mode. Okay? Now I can run the code step by step with this button here. Step will go over this statement and will run it. So A has already been computed and its value is 1. Yeah? Now I can step in B and I will get the value of B. But I can do something different. I can step in a function. Recall that minimum is already a function we define. So if instead of using a step, I use step in, it will step in this function minimum, and I will be allowed to do a step-by-step execution of the function. Here, for example, A is 30 and B is 20. So A is not smaller or equal to B. So that's why it's checking the else condition. Yeah. I will do the step. This is the case, so M will be equal to B. Step, it will end the else, the if condition, then it will end the function and it will return to the main file. Now it will assign to C the value of the output variable, and we will see that the C value is 20. Okay? And then last step, it will end the debugging mode. It's very useful, the debugger. For example, when you have for loops, you can follow a step-by-step execution of the code. You can run, it will stop here, and it will ask for a natural number. Then it's telling me it's stopped here where summatorial equals 0. So I will step, and then I will enter the for loop. And in this way, as I'm doing a step-by-step execution, I can see the value of I. Yeah? Now I equals 2. If I step again, I equals 3. If I step again, I... Oh, sorry. What I did, oh, okay, because that was the last step. So the final value was I equals 3. Yeah. So that stopped the debugging execution. So K letter is gone from here. So this is how the debugger works. It's a very useful tool to find bugs. It's very useful tool to check what the code does, which is not always what you expect it to do. Yeah. Okay, so that's it. See you in the next tutorial. Bye bye.